to do a little video today and talk about the chiller panels. What is a chiller panel? What is in the panel? Some basic operating history. So I'm here in this plant now. Over here behind me I've got 5 modular chillers. So a little bit about what a chiller does. It basically produces cold water for the building's air handling units. As opposed to like residential heating using equipment for cooling. We do use refrigerant for this system, but it's going to make the cold air will make it chill. So that being said, we're trying to absorb heat from the air so that we can cool the air that's around this cool by removing it. So when we blow warm air from the building across the chill water coil in the air handler unit, heat is transferred from the air to the water. So the water may go out to the building, say 44 degrees, to all the chill water coils. And as that warm air passes across the water coils, that heat is transferred to the water, which means water is going to get warm. It's going to pick up some heat. Typical design, for a design day, which is a hot day, would be like a 10-degree temperature rise across those coils. So that being said, if we're putting 44-degree water into the building, we would expect to see something like 55-degree water coming back to the chiller. So that being said, these chillers then are going to stage up compressors so that we can bring that temperature back down to a leading 44-degree set point. So when we absorb heat into the water, we need to get rid of that heat somehow. So the refrigeration process, we're going to compress a vapor, cold vapor, into a hot gas temperature. And we need to condense that hot gas at a temperature that is much higher than, say, the condensing medium. In this case, that's going to be, we do have a couple of cooling towers here that we'll walk you out and show you that. So we absorb heat from the air, in the building, and then we need to reject that heat somehow. So basically, heat is just kind of like jumping on a train, going from one place to another. So anyway, we'll walk out here and we'll take a look at the cooling towers now. Here we go. Alright, this is an Evapco cooling tower. Kind of the way this thing works. As you can see, we've got a fan on each tower. Up top, we have a damper assembly. And then over here, we have a spray pump. And so what happens is that warm water comes through the wall from the chiller on the condenser side. It's pumped up through these pipes. And as you can see, that's fluid in and that's fluid out. So what's going on here is this tower uses the evaporation process to cool the water back down. So we may see, ideally, like 95-degree water entering the tower. And then as that water falls down over like a fill media, it causes the water to flash off and actually that's what cools the water. It's the evaporation process. So if you think about, if you've been out sweating and your skin has sweat on it, if you walk into a cool, dry environment, that sweat's going to evaporate. And as it does, it actually cools the skin. So we use the same process with the cooling tower. It's the evaporation process is what cools the water. Now the fan does aid in that, but the majority of the work being done cooling-wise is going to be evaporation. So that's our goal here. So we need to have a cooling tower that's functioning well maintained. We've got to make sure that the distribution tubes up in the top of the tower are clean and clear. So what we have here, we have this Evapco Pulse Pure water filtration system, and they work fantastic. These things do a really great job of keeping the water clean here. So clean water is really important. If you don't have that system, normally you'll have like a chemical treatment agreement in place, where somebody comes out constantly is adding chemicals to the tower via a automatic feed system. So a lot going on out here. These chiller plants can get really complicated. They can be intimidating as well, especially in a LEED building like this, where we're really big on saving energy. There's a lot more parts and pieces and control strategies involved to be able to heat and cool a building and do it with a lot of efficiency. So these towers there's two of them here. That's just one aspect of the system. Now, obviously, we're talking about moving fluid here, so we're going to have some pumps to do that. Let's come in. Let's go look at pumps now. So here we have a microprocessor. This is the Susticon pumping package. We actually have 4 of these pumping skids on the site. The one we're looking at is the one that pumps the fluid to the cooling towers. And you see we have some ADB frequency balance. They're going to vary the speed of the pumps based on a set point, which is calculated in the microprocessor. So basically, a chiller plant has got multiple microprocessors that control at what I call low-level devices. And then we have a master microprocessor for building management system, building automation system, some call it. And that basically goes out and talks to all the microprocessors in the plant. And it makes sure that that everything is working together in unison with each other, because all of these different subsystems really have got to be tuned to work with the master panel. When that system is tuned, then we're at optimum performance. If we have, all it takes to is one temperature sensor in this whole plant, I can shut it down. Yeah, one little sensor can do that. So it's very important that maintenance is done, that all these things are inspected, checked, periodically. It's always good to have spare parts on site as well. So yeah. Well, anyway, these guys here, they're pumping the fluid out to the system. If I turn around here, I've got another Susticon pumping package. And that one is for the chilled water. That's the cold water being delivered to the building to the air handlers. Alright, so very important that this thing is working properly. So there are like pressure transducers that actually measure water pressure on the entering and leaving side of each pump. If one of those fails, that pump is going to shut down. So luckily we do have redundancy here. Redundancy is very important in a plant like this. You don't want to have just enough to get the job done, because as soon as you have a failure, you lose capacity and you lose your building. And we don't ever want to do that. Let's come over here. So here we have our chiller microprocessor. That controls the 5 chiller modules. It stages them up, destages them when the load drops off. You can also determine what mode of operation the chiller module is going to be in, whether it's cooling or heat recovery. We walk around here, we've got another pump skid. And we've got some boilers make heat for the building. We actually use heat in the summertime for what we call reheat. The VAV box may overcool because it needs a minimum amount of outside air being fed to it. So sometimes it could overcool the space, and we use hot water reheat. That's where heat recovery works really well with the children, because we can make chilled water and reject the heat into the building back into the hot water loop as opposed to sending it to the cooling towers, because that can be wasteful with the hot water. Noisy in here. And last but not least, there's a hot water pump package. Over here we have some plate heat exchangers. I saw another video yesterday that I stripped one of them down. There are the plates. And that's the frame that it came off of. Okay. So a little bit more about this. This is like I said, it's a heat recovery chiller. And this is called a 6-pipe chiller. So if you look at this guy here, notice these two have foam insulation on them. These two do not. And these two do not have insulation. The reason these two are insulated is they have cold water flowing through them. And basically, my chillers, these actually come separate to the job site. But they have main 6-inch water heaters, and which I believe these are 8-inch. I'm sorry, these are 85-ton models, so they have 8-inch header. That header is actually flowing inside the very loud in here. So all of those get coupled with Victaulic fittings, so that you basically have one long, consistent run of piping for these models. When that happens, we then have 2-inch pipes that come off of these headers, go down to these heat exchangers. So we have motorized valves up inside of these. There's 8 motorized valves per module that are indexed based on the mode of operation. So let's just say we're in cooling mode on a module. So these 2 pipes are going to be active. We're going to have chilled water return coming back to the chiller, 54 degrees. We're going to route that 54-degree water down to this evaporator. The pressure comes on, and it's going to cool that water down to 44 degrees. So it leads out of here and somewhere in that range. And that cold water goes back up into the other pipe, goes down to the end where it then leaves the chiller and is pumped out to the building. These 2 pipes here, these are our condensers. So in cooling mode, these 2 are going to be active. So our motorized valves for the condenser heat exchanger, they're going to be indexed to where we're rejecting our heat from the refrigeration process into the 2 condenser pipes. Okay? Now, if we want to do heat recovery, what we can do is we're going to be in cooling. We're still going to we're going to extract heat out of the water, so we want to do something with that heat. We want to make a good decision with that, and instead of just wasting it and sending it out to the cooling tower to be dumped into the atmosphere, we can index our valves where we're going to run the hot water circuit through our condenser. We're going to dump that heat into the hot water loop, which then we can use that as it's basically free heat for our reheat system. So it's a lot more complex than that, but that's kind of the overview of how all this stuff works. And, so for those of you in the HVAC world that have a big interest in chiller plant work, it can be complicated, but it's like an elephant. You eat it one bite at a time. You kind of break it down into little subsystems. It's not as complex when you do that. Keep it simple. Like I said, just break it down into little pieces and learn them as you go, a little bit at a time. And over a period of time, you'll figure it all out. So yeah, a lot of piping here. A lot going on, but there is a rhyme and a reason for everything. And there's a purpose for everything. So it's important to get to know your chiller plants, know the characteristics of them, so that if you do get a trouble call, you're not scrambling trying to figure out where everything is. So study your plant, and if you're the guy doing the maintenance of the plant, study it, in fine detail. Make sure you have some critical spare parts on site, and just like really dig in and have a good understanding of what you're working with. That way you can support your customers a lot better. So anyway, hope you enjoyed the video, and talk to you later.